Now.
We're ready.
Hi, everyone. Welcome to our live broadcast from Idea to Reality, getting it right the first time with the CNC Digital Twin. We've got a great topic to present today, a solution that is becoming even more and more common on the shop floor, where real-world challenges are meeting cutting-edge virtual solutions. My name is John Meyer. I'm the Marketing Communications Manager for the Siemens Machine Tool business, and today I'll be your host and moderator. Before we get started, I'd like to cover three general topics. First, today's webinar is being recorded, so after the broadcast, everyone will receive a link to the recording so you can go back in case you miss any part of the conversation and demonstration. Second, to prevent any interruptions, all microphones have been muted. And third, should you have a question about the content being presented, please use the question field in the upper right-hand corner of your screen. We'll have a Q&A session towards the end of the broadcast. By the way, also in the upper right-hand corner, you'll notice a PDF of a white paper we just published. It's a really great resource, and I highly encourage you to download it before the end of the broadcast. So imagine you're a manufacturer operating in a high-demand environment. A customer reaches out with a last-minute request for a custom part. The design isn't finished, and you know changes are coming. Your production schedule is tight, your resources are stretched, and there's little margin for trial and error. Does any of this sound familiar to you? Well, this is where digital twin technology becomes your new best friend. During today's webcast, my colleague Chris Pollack, also known as Mr. CNC, and by the way, you should subscribe to his YouTube channel if you're not following him already. Chris will show you how he tackles a similar challenge by preparing and simulating his workpieces virtually, making real-time design changes without interrupting his production, and validating and optimizing his part programs before they even hit the machine. All of this leads to no downtime, no scrap, and definitely no stress. All right. Without further ado, I'd like to welcome Chris. The stage is yours.
Well, thank you, John, and thank you, everybody, for joining us today. Super excited to spend a little time with all of you. As John mentioned, we're going to be digging into the world of what we like to call digital twins. It's kind of a loose term these days, right? There's all kinds of quote unquote digital twins in the market. We joke around about it, but you can have a twin, but maybe it's your digital brother or digital cousin, or it could be that neighbor 3 doors down, right? So there's all kinds of different variants. So what does the digital twin mean to us here at Siemens, and how can it help you in your day-to-day job is really what we're going to look at. So we're going to kind of dig into just the basic fundamentals of high level, what are digital twins and how are they applied into the industry? And then we'll dig into the topics. And don't worry, I didn't prepare too many slides, like 70 or so we'll have a good time. But we'll mix it up and we'll put a little bit of live demonstration in there as well. But I do want to set up the topic first and kind of talk about the digital twin. So from our world, there's really two base applications that we would apply this technology in. There's the application of creation of the machine tool or the object. That's what we think about from the automation machine side. And then there's applying the machine. So from the automation side, this would be really used by your OEMs that are building your machine tool. Maybe it's a system integrator that's taking an older machine and upgrading it to a newer control like the Cinemeric One. Or maybe it's somebody that's adding in advanced high-level automation into the system, and they want to be able to simulate that whole process. Now, once you've created this environment, then it comes to applying that machine in the final application. And this is where me, the end user, can start to use this tool and allow it as part of my workflow. So however I'm programming, I can then bring it into this environment, and I can effectively digitalize the entire machining process to check Is my setup going to be okay? Do I have enough travels, right? All those things that might stop my machine from producing parts. I want to get in front of that. I don't want to have that, oops, we don't have the fixturing. We didn't look into that. Maybe we have the wrong tools. So the first piece, that automation of the machine, is really going to be serviced by a product we refer to as Create My Virtual Machine. This software is designed for a machine tool integrator or OEM to be able to completely simulate the commissioning of the machine tool. So imagine what the process would have looked like. Oh, excuse me. Sorry about that. Forgot to shut the ringer off. Anyway, imagine what the whole process would look like traditionally, right? If I'm going to build a new machine, I'm probably going to have to design the machine components, start to cast, maybe fabricate the pieces of the machine. And not really until I get to the point where everything gets bolted together, can I think about starting to actually commission the control and then run tests on the system. Well, that comes at the end. Well, with this software, I can do these things in parallel. I don't have to wait for the physical machine to be built. I can take the models and create a virtual world of this machine, and I can start immediately commissioning, writing the PLC, doing all these steps way before the first parts even cast. Now, when it comes to the end user application, this is where we use a product called Run My Virtual Machine. And Run takes now the existing digital twin file, we refer to it as a VCP file, and allows me, the end user, to apply it in my real world kind of day-to-day tasks. So I can start to methodize my job, maybe bring in my vise, bring in my work holding, validate that everything's going to machine properly. What's my cycle times? Is my program got any issues? You can fully simulate that entire process. Oof. I thought I remembered to shut my ringer off. Hold on one sec. It's my boss. I don't know what he needs, but he's going to have to wait. He knows I'm doing this event. Sorry, guys. So anyway, with that being said, we're now going to start to dig into these two products in a little bit more detail.
Hey, Chris.
Dave?
Yeah, are you there? Can you hear me?
Dave, what are you doing in the event? I'm in the middle of doing a webinar. How'd you get in here?
Yeah, well, you didn't answer your cell phone, so I just called through the computer, and here you are.
Okay. Well, I'm in the middle of an event. We have a lot of friends here that are seeing your face right now and hearing you speak.
Okay.
So what's up? What do you need? Real quick, I want to get back to my slides. I got a lot of slides to get through.
So I'm assuming you're presenting, your standard 140 slide deck to the audience.
I got
right?
it down to like 78, so we're okay.
Okay.
We're going to be here for about 2.5 hours. Not too bad.
Okay. Well, yeah, that's good. So we have a bit of a challenge, Chris. Remember those bottle openers we made for our customer? For the
the 400 I shipped out last week. Of course,
Exactly.
they have their event on Monday. How could I forget?
Yeah. Acme CNC, right?
Yeah, Acme, like Roadrunner, and the
No.
what do you mean no? Acme,
It's
ACME.
yeah. No, not like the Looney Tunes. We have to look a little bit closer at the name. It's ACMIE.
Are you telling me I machined all those bottle openers with the wrong name, Dave?
I'm not telling you did that. I'm just merely suggesting there's a misprint in the name.
All right, I tell you what, we were going to jump over to Run My Virtual Machine at some point in the webinar. I do have it pulled up. Why don't we take a look, because I have a hard time believing you, but I'm not going to say you're wrong. I'm going to use the tool to prove you're wrong. So this is the digital twin. If you don't mind, we'll kind of show off the product as we talk this through, Dave. I don't want to make this too boring for the audience. So what you're looking at here is effectively the piece of software we refer to as Run My Virtual Machine. It's identical to Create. It's really just access levels is the core difference. We limit how many machine parameters can be adjusted, some of the things that really should be reserved up to the OEM. Really difference is instead of it saying run right here in the upper left corner of your screen, it would say create. So we have two kind of areas of the software. On the left side of the screen, you should see the HMI. So this is the Cinemark One control, and this can be created from the reel. So the machine behind me, as you see kind of over my back shoulder, That is my CM20 from Fryer, and we built this digital twin from data I've sucked right out of the real machine. And then certainly on the right side, that's the whole 3D environment. So if any of the people on the audience are used to Sinutrain effectively what you have on the left side with the HMI and the machine control panel. But what we get now is not only that, but we have the whole 3D space. So now I can bring in my work holding, my tools, my workpiece. But what we need to do is we need to take a look at the HMI side, and we need to look at the program to see if I did this mistake, which I don't believe you. But let's look. So I like to work from a shared folder. This way I don't have to transfer stuff back and forth to the machine. So this is the main program handling my bottle openers. And if we come right down here, we can open it up, and yeah. Yep, I spelled it ACME. And you're saying it's IE?
That's correct.
Okay, easy fix, no big deal. I'm just gonna put an I right in here, look at that. I say accept, I go down to the second one. I'm gonna do the exact same thing. And let me just drop that in here, the beauty of the digital twin, right? I should have had you look at this before I cut them all. Now, on the bottom, we're still putting Cinemark 1, is that correct? I don't have to change any of that?
That's absolutely fine.
All right, so if we take a quick simulation, I can use the simulation in our editor just as a kind of a quick validation or prove out. All right, do a little drilling here. I'm roughing it out. I can look at it in 3D if I want, certainly rotate or pan it around. Something like this, obviously we want the money shot, which is the top. So we're gonna take a look here. Now I do come in, I do all the deburring, so I didn't have to get out the old deburring tool, which I happen to have in my hand, but I don't want to use it. So we'll do a little quick deburring, and now the engraving. Drum roll, please. Okay, so ACMIE CNC. Look good?
Can you zoom in a little bit more?
Sure, let me get right in here, and there's your money shot.
Yeah, perfect. Okay.
Good.
Now, quick question though. While we're here,
yes, Dave. Here it comes, guys. I hear coming from here. Yeah.
To change the font style. That looks a little, not so good.
So traditionally, in the engraving built into the Cinemark control, no. So we could do uppercase, lowercase, special characters, but it was always around the same font. Now I do have something that's pretty cool that we've just released, which I happen to have set up in this machine, which is called our SMTE cycles. Another acronym for you to learn from the Siemens world. But what it does is it's actually the ability of us adding in extra cycles to the control that it wasn't necessarily built with. So it's a real easy lift. I can have a machine in the field and I can get these different cycles. So you see I get this new add cycles tab here, and it says engraving. I can have a whole pile of cycles. I think right now to date we have, I think maybe 6 or 7 released. We have chatter avoidance, we have tricoidal milling, which is pretty cool. I haven't put them all in this machine, but this would be a path to kind of get you to your font. So if you look, if I launch this cycle, I do have now the ability of supporting multiple fonts. We even have our Siemens fonts. And believe it or not, and I can't believe I'm telling you this because I know what you're going to say next, so forget it. But there is a way to bring in custom fonts if the company had their own font. But don't even go there. I haven't even done it yet. I'm not going to start doing it now. These guys need these things for Monday. There's no way I can do it. But we have some fonts. So I think we could find something here. So why don't we add this to it, and we could take a look and see what you think. So what I'm going to do real fast, just because I didn't memorize all of the data I put into the cycle, I'm just going to use my handy dandy little snipping tool. I'm going to capture this cycle. Boom, boom, boom. Where'd it go? It's hiding. Okay, I'm going to throw this on my other screen. The beauty of multiple screens. If you don't have multiple screens on your decks, get it. I wish I had 4. Okay, So now we're going to plug in our SMTE cycle, and hopefully this will satisfy you, and we can get back to my absorbent slide deck. Okay, so we jump in. I got to give it a little data, right? So like, where do I want to retract? So maybe I'll retract up to 5 mil when I'm done with the cycle. How close do I get to the surface maybe as I start to feed?
Hey,
What is my feed rate during the engraving versus what is my plunge feed rate? So this is a tiny little 1 millimeter ball I use for engraving. So I'm going to slow it down a bit.
Are those only metric?
No, of course it's not all in metric.
Can
I
you
happen
use
to
inch?
write this all in metric, but yes, we could certainly do this in inch. But yeah,
Okay.
180 is not inches per minute, it's millimeters per minute. So good,
Gotcha.
good guess. Got to remember, we do work for a German company, so we do like our metric. But no, either way, not a problem. I can wrap my text around arcs. If anybody out there is familiar with the traceil command, our cylinder surface wrapping, you can use it with this cycle. We do have a couple different ways to engrave the text. So the original was only center line, but I now can do kind of frame. So why don't we try frame? That might glitz it up a little bit. And then from the text, I'm kind of partial to this Tinos font. So why don't we try that and you can tell me if it's okay. We can do bold, regular. I can drive the text in from other areas, but I'm just going to type it here real quick. All right, ACMIE, right?
Correct.
All right, and now let's plug in just some basic numbers. So this is what I'm stealing off the other cycle, just kind of where I'm positioning this on the putter, because that's pretty critical. Top, depth, I went minus 0.051. Yes, metric. It's not 50 thou deep. It's, we're going to go my width or my letter height and no angle. So I fill out the page very kind of similar to what a user would expect from a traditional cycle. Now it is going to show you the text in a little bit more like a G-code kind of format. But if we go to Sim, we can validate it. So let's back up. And I'm going to leave the other one there so we could even do a kind of a side-by-side comparison. So a little pro tip. If I hit Control M, it's going to increase the speed to max. And then I can toggle back to Control M again. And now it's going to get into the next operation. In this case, it's creating a G-code file. Since this isn't a native cycle, it works a little bit more like a CAM system would. It actually posts the code out. And then I get my Acme CNC. And from there, it's going to refresh. So you can see where it kind of frames around. Versus, oh, you know why it looks funky? This is the beauty of simulation. See how it looks like I have 2 A's and 2 C's?
Yeah.
You never told me to delete the other cycles. We have both engravings underneath each other. All right. So we got to remember to get rid of this one because we have 2 on top of each other. Okay. See why I like the digital twin so much? That would have not been fun if I did it on the real part. All right. Okay. Pro tip again. Control M. Going to speed everything up. And now we're into our regular engraving. Yeah, that looks a little better. So we have the framing, certainly versus the traditional. All right. I agree with you. I think the new one looks better. You happy? You like it?
I'm getting there. Actually, I'm a bit concerned, though, with the amount of space there you have in the bottle opener to actually pop the top of a bottle. It looks a little small in your rendering digitally.
Well, I did test them the other day when I did the prototype, and it worked certainly good on a Budweiser.
Well, of course, the 4th of July holiday. Why wouldn't you test it, right?
Well, of course, yeah, absolutely. So what are you complaining about? This geometry right in here. This is where
exactly. Yeah, where the hole is. Yeah, right there where the hole is in the bottle opener. Can you make that like a little bit bigger?
Okay. We can try. I will tell you that when I designed this, I designed it in a CAD system. So I did use the DXF converter to bring this in. But the way it works in our control is kind of interesting. I can do some modifications. So let's see what we can do. So if you look at the program, and I did this all conversationally in this case, but you see how I have this contour path 1, contour path 2. So anywhere you see path 1, that's going to be the bottle opener on the left and it exports it to this format. So as you come through, kind of each of the elements as we pick them is features of the bottle opener. So probably somewhere, I don't know if you can see it, Dave, but you see how it kind of highlights blue? That's my indication where I am on the geometry.
Yeah.
And right there, I'm into this area. So if you look, currently it's a, I'm defining the endpoint from the start as 7 mil in the positive. So what I could do is I could go in and see what will it do if I make this a little bit bigger. All right, so I accept it. Yeah, you see how much it increased that? You like it that way?
Yeah, that looks a little bit better, yeah.
All right, so now looking at it, the one thing I don't love is look at how sharp now we have the transition of this back wall into that arc. What I think we should do is if we go to the next element and we go to its radius, this is what's called an end of line function. So basically I can, at the end of the line, I could say, hey, I want you to blend a radius or a chamfer into whatever comes next. So even though I got an arc coming next, it's smart enough to allow me to blend it. So that's a 4 mil radius. Let's try a 5. I kind of like the 5. This way we can kind of maintain a nice consistent thickness. What do you think? You like that?
I think
I
that'll
like
work.
that.
Yeah.
I think that looks pretty good. So let's save it. And now I'm just going to leave this one alone. Since the path is automatically linked, if I go into the next one, you'll see it already knows the edit I made. So I don't have to do anything else. You know, the first one is my roughing up. So here I'm using a 3/8 tool. Hey, inch. Just kidding. I'm using a 3/8 tool and I'm roughing it out. And then I come down to the bottom one, 3/16 tool is going to be my finishing operation. So if we simulate it, we should now be able to, again, compare the two bottle openers. The left one's been optimized now. The right one is still as original. I'll come back. So there's my roughing. So now you can see now this tool is automatically going in much deeper than it is over there. And when we get to the finish, it's also going to accommodate that. So the only thing that I don't know for sure, I might have to play with one that is a little bit heavier cut in here. So we might have to slow down the feed rate on that feature. We can actually do that right inside the cycle. A lot of people don't realize. So we'll give you another little pro tip here. It's doing the engraving finally. And there it is. So there we get the money shot of what it looks like kind of side by side. Yeah, not so bad. I like it. So let's just see if there's something we can do right in this little feature. And if we're happy, let's run this thing over on the 3D side, because then we'll really get to see what it's going to look like. So again, little pro tip. In my contour, I can go down to maybe this feature. And if I go to all parameters, there is this field, this FS field. So I can actually put a feed command in and it'll change the feed rate in this portion. And then I can maybe kick it back up. So if I looked at my original cycle, I am finishing this at 873. So maybe I want to drop down to 600 just because I know I'm going to get a little heavier chip load when I roll through and finish that with that tool, because that 3/8 tool can't fit in that feature. So we're going to do maybe 600 and we'll do it right there. Remember, go in, all parameters, We'll do an F of 600, and then it should maintain. I just got a few more moves, so I'll just leave it at that, and that should be okay. So see if I get any syntax errors. Anytime I do any kind of edit, I love to run it quickly through the editor here, just because it's a pretty fast simulation. If I did type something out or, mistype something, I certainly would catch it at this point. But now, before I would cut, I definitely want to come over to my 3D side. So what's cool is I'm going to use this as if I was just running the machine as normal, right? Now, the difference is I did bring in a vise. So the way I did that is I went to the library. I created a setup. So you can see I have a bunch of different setups here. Some previous ones from when I did the Christmas ornament. Here's my bottle opener setup. So you kind of build up this setup. In this setup, I can bring in unique stock models, or I can create the stock models from parametrics. I can bring in any vise I want. In fact, when I'm building the setup, I can also bring in my tool adapters. I can bring in unique tools. Like here, I have a Kennametal cutter that I brought in because I really want to be able to simulate the whole process. And once you've brought in all these components, you kind of put it together over here in the machine space. So now it's as simple as running the machine as I normally would as an operator or user. And now I'm going to see my machine tool start to cut my part. So there it's kind of simulating what the behavior would look like for the tool change. And we're down and we're running.
Chris, do you have any idea then in terms of making these changes, how long it's going to take you to run another 400 pieces?
Yeah, so at the end, what we'll do is we'll take a look at the cycle time counter, and that'll give me truly a one-to-one representation. Usually, that's the only areas that may be slightly off. If I look at chip-to-chip time, in this case, that's not a servo turret, right? This machine behind me has got what we call a Geneva drive on the tool mechanism. So I'm not going to know exactly how much time it takes to tool change chip to chip. So even if I wanted to add in, maybe 5 seconds, 10 seconds max per tool change on top of that time, that'd be about the only thing. On a servo driven tool changer, for sure, I would get basically a one-to-one because it now knows how long it takes to spin the carousel. That's about the biggest loss of time. So we got some holes popped in it. Now we're going to come down and we're going to start machining out the contour. There she is rolling around profiling. Now I bet you I know what you're going to ask me next. Let's see here. 3, 2, 1.
Why is it orange?
I was waiting for that.
Does that mean the tool collided with the fixture?
Salesman, you got to learn your products, my friend. No. So what this is telling me is this is what the system calls a near miss. It's just warning me that I'm within a set gap distance of the part. So I'm okay with orange. I know I'm getting close to this fixture, but I certainly have enough clearance. I've kind of worked that out. But if I want to suppress it so I don't even see the orange, I'm just going to click the little collision detection off, and now it's going to run through as normal. Now, what is cool, a lot of times what I'll do, especially on longer runs, I'll just let this thing run. I'll go grab a cup of coffee, get on some emails, and as it's building or running, anywhere it sees either a near miss or a collision, it's going to record it for me. And then I can click on them and take a look to try to figure out, what spot it maybe has this collision. So you'll notice it actually highlights it, stores a little 3D image. So in this case, it was saying, hey, see, I'm pretty close to the fixture. It's actually saying I'm pretty close to the vise, but you can see the clearance. But clearance is clearance, right? So we are good. Yeah, if this was red, that would be a time for me to worry about it. And then I would want to go back and see, should I move things up? Should I get away a little bit? Is it just model inaccuracy? That's one of the challenges when you get into this whole digital twin scenario is how accurate is this vise? Is this vise truly a one-to-one to what I have sitting on that table? and it may be off just on tolerances. It could very well be off just because when the OEM built it, they didn't build the vise exactly accurately in the model to what they're shipping as product. So it happens. Usually what I'll do when I get a new vise or some work holding, I'll do some basic checks, right? So I can simply measure this. Real easy to come into the setup area. There is a cool measure tool here, and then I can start to measure different features, right? I can say, how long is that? And it'll start to give me those dimensions, right? As I measure it. Oh, that just jumped in my way. All right, that distance is 37 millimeters, right? So I can analyze the model. And then what I'll do is really just take my probe on the machine, come down and say, well, I know where the bottom of my table is. So let's say I was checking to the top of the vise. Is it really that dimension? And if it's not, I just want to take that into account when I methodize stuff, that there's a little bit of discrepancy, and I want to be aware of that. That's
so Chris, it's going to give you a warning if you're getting too close to the fixture to prevent any
exactly.
collision.
That's exactly what it's doing.
So is there also any spell check available in that system that would maybe give you a warning?
Hey, I spelled it right. I can't
just
blame that these guys don't know how to spell their own company name. I'm just saying, hopefully they're not on the event right now.
I hope not. Yeah. Yes.
All right. So we've kind of walked through. We got our prove out. If you look at it now from the top, you can see even in relation to that hole. Now we can suppress different things. So like maybe I get rid of my guarding and my base. Right? So sometimes I want to kind of bring it down to the least amount of objects in my way. But now if you look at the hole versus the pocket, I definitely am taking a lot more material out than I was even with this one, right? You see the distance? So I'm pretty happy with that. Should we set up one to cut?
Absolutely. Yeah. I think everything's cleaned up now, right?
Why don't we do that? You know what I'll probably do, instead of going through the whole process, maybe I'll cut one so we can have a side-by-side. This way we get a kind of a final check for sure if we like each sample. So what's pretty cool, I'm going to shut her down now. I'm pretty happy with where we've seen it. At this point, we're about 5 minutes in on op 1. So I would say probably total, the other side doesn't take much longer than maybe a minute. So we'll probably be 6.5 minutes for two bottle openers. Not the end of the world, although I'm going to probably have some late nights now, but that's okay. So let's just jog her up, treat it like a real machine, put her in a safe spot. Now in this case, the model that you're seeing on the screen is not connected to this machine at all. We get different products for that if you want to go that far. But what I am doing is I'm sharing a lot of stuff. So I don't like to have to use the good old-fashioned sneaker net, right, to run my program over to my machine. I want to try to automate processes. So what I've done is I've created a shared folder in my program manager, and that's my programs 3 folder. So I showed you this briefly before. What's neat is program 3 is what I would have back here at the machine tool. So if I go to the real machine, go program manager, you'll see program 3, and the file that I was editing is immediately at the machine. I don't have to do anything extra because it's sitting at the machine tool. So I could come in, I can start to validate it, right? I could check the program just kind of like we did before. So if I wanted to maybe look at the shape, this is a good way for me to validate, hey, I can see my pocket change, right? My edit. Maybe I want to look for that feed change. Oh, there it is, my feed 600, right? So I can do a quick check. I still have all the graphics like you saw over there in the editor, but now I can drive with confidence. So I don't need to go through all that crazy stuff. I have faith in my twin as well as I have faith in my reel. So I'm going to jump over to execute, and we'll always, 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 I don't care who you are, if you're going to run a program that's never been run before without cranking it on the override, you're going to crash your machine. Maybe not today, maybe not tomorrow, but it will happen. So I always like to just double check, make sure everything looks good. All right, so there I'm about 2 mil away from my end of my surface. Get down to plane. As long as this tool is good, I know I'm golden. All right, so we're cutting the part right now. We'll let her do her thing. We're kind of into the event a little bit, so I tell you what. Why don't we take some questions? So Dave, what kind of questions do you have for me as we're cutting this thing?
So clearly, the application that you're using on the digital twin side, right, allows you to not work on the machine and do all this digitally first. But also, I mean, this seems like it could be a really good training tool as well for, your team who's new to the machine tool and can use the control or the digital twin to, test and create programs, move the machine around, just a testing environment, right?
So, I mean, that's a great point. And we're seeing this product really get traction in kind of two environments in that topic. So certainly we have a lot of Votex. We have, you can even hear it clearing that pocket out. We have a lot of Votex, community colleges, even universities that are starting to implement this software into their programs and train their students in this process. And the one reason why they'll do that and where this is such a good fit is, look, let's face it, a 5-axis machine is not a cheap acquisition. So I now have a sandbox where you can effectively teach the students any technology you want, as long as you have a digital twin file prepared for it, and get them exposed to it without the need of an expensive machine. And even if you have, let's say you have a 5-axis machine, the probability is you can't afford to have 10 of them. Right? So how do you get 20, 30 kids in a class? Real stick time, right? Real seat time. Well, here they can do the whole process. So I can actually go in and even mimic the setup. Mm-hmm. So we'll see that in your traditional education paths. But what's interesting is, a lot of customers, a lot of end users, it's hard to really find qualified people, and there's not always a lot of educational institutions around where they can kind of allow them to feed their workforce. So there's a lot of workforce development happening right at the OEM. And in that case, the OEMs will actually have this software in a training room or environment somewhere, but they're actually setting up their machines, right? So maybe I'm ABC Machine Shop, and I can now have 5, 10, however many machines I have represented in this space. And again, it is the full machine space. So I can literally go, let's say, to Jog, go into maybe TSM, and run this thing as if I was running the real machine. So I can do a tool change manually to, let's say, a probe. I can take that probe, jog down, come down onto the part, do my process measurements. I mean, however I want to kind of move through the process, I can simulate even the jog portions of the setup right within the software. So I would say either application is really powerful from the educational side. So with that was a great question. I hate to try to get back into the slides now, but let me reach out to Mr. Meyer, who I think is still on the line, and see if we got any questions maybe from the audience we can discuss.
Yeah, absolutely. There are some questions that have come in through the question panel, and there's some questions here in the chat. So let me start with, are there any open source software for creating digital twins?
Open source software. So certainly our platform itself does require my virtual machine as kind of the delivery mechanism. However, the software that we use to actually create the 3D models, although developed by us, is available for anyone. Doesn't require any kind of licensing. So you can use that tool to start to put together the machine side of it. I hope that answers their question.
There's also a couple questions, Chris, more on the technical side around grinding applications.
Sure.
Does Digital Twin work with custom dressed grinding wheels?
Absolutely. So we've done it a couple different ways in the past, but effectively I can create what we would think of as like a form tool for a lathe to represent the profile of the grinding wheel. And what we'll do is we'll take that singular cutting edge and effectively embed it into what looks like it's representing the wheel. We certainly need some form of a cutting edge to then apply that profile on the mating stock. But at that point, then yes, we can cut the stock model. We can get the shape of the grinding wheel that's been dressed on it, basically embedded into the stock model. Now, your stock model that you were looking at before, right? The stock model, that's going to be the only thing that can be machined away. Anything else would represent a crash if I was to hit it.
Another question that came in through the chat. I want to set up a manufacturing unit for cutters and drill bits. How can you guide me?
Whew. That's a good question. I don't know necessarily how I would answer that, only because I don't myself happen to engage with a lot of cutter grinders. We certainly do have some cutter grinders that utilize our technology. I would say probably the biggest grinding importer that we know would be United Grinding. I would probably reach out to them to see how they're implementing some of this technology, and maybe they can kind of work with you from that perspective.
There was a question about where do I go for a quote on Run My Virtual Machine. So Dave, I put your contact information into the chat. And I've also, and for everyone, I've also put in a link for the free demo version that they can visit our site directly and download it straight from there.
Perfect. Good call, John.
All right. Then another comment was, I really like the demonstration. Thank you. If I want to implement the CNC Digital Twin, where do I start?
That's a good question. Certainly. I mean, this whole world can be kind of very overwhelming, right? So I am going to jump back to my slides just for a brief second, because what you can do, and I'm going to come down here a little bit, is a lot of people don't realize we have a free version, and that was what John was just talking, or a demo version available to you. So if you go to our CNC for You, CNC for You website, on the CNC for You website, you can get to the RMVM demo download. And from there, just click on it. Really painless lift. You will have to obviously type in a little bit of your information. Excuse me. You do not have to opt in for marketing. It's totally up to you. If you do, they will send you just a quick email to validate who you are, but it doesn't matter. You don't have to. Download the documents right here. That's in red. That's where you're going to go to get the software. Now, what's neat is with the software, you're immediately going to get 3 machine technologies: a 3-axis mill, a 5-axis 3+2 machine tool, and a lathe. And we do support this in both a metric variation or an inch variation. For those of us that prefer inch, which I usually do, to be honest with you, you can have either or. The demo version, you can play with this. This can be your little sandbox to fool around with it. If you like it, then at that point you can get a full version license, and then from there you can kind of decide. I have a lot of users that just end up using these demo machines because they're close enough to their machine type to do the same process I just did. But if you want to go the next step and maybe get a little bit more detailed, you can look to maybe create your own HMI version that's a match one-to-one of your machine. Or the best scenario would be reach out to your OEM, see if they're providing these digital twin files, and then you can import them right in here. And there's no limitation to how many machines you can have. So I could have 100. In fact, I think on my regular PC I do, of all sorts of different OEMs that we work with that we're promoting their product on. So that would probably be the best path. Get the demo version, play around with it a little bit, see if it's going to be a good fit for your process. I think it will. If you have questions on it, don't hesitate, reach out. I'm going to give you my email address here in a minute, or Dave. You can certainly bother him as well. But I would say that would be the best step and process to kind of going down this road. Great question. Thanks.
Chris, Dave, a couple other questions that came in.
Perfect.
Is there any interoperability with another control such as FANUC?
Good question. So obviously, at the end of the day, it's the Siemens brain, the Siemens kernel that's running this thing. But what is interesting is we actually have the ability, John, if you could just share my screen real quick. I'm going to jump back to the software. So if the machine was commissioned with what we call our ISO mode, see how I have this H column? Mine absolutely is. What that means is I can actually run effectively straight FANUC programs in this machine. So if I just want to use it to do some basic proof out of a FANUC program, it's not going to be a true one-to-one digital twin to your FANUC equipped machine, but you can certainly run your FANUC programs through it and at least validate that the programs are going to work within this environment space before you walk them over to your FANUC machine. So you can get there. It's a little more of a hybrid.
Okay.
I'll switch her back to our Q&A.
Can we connect digital twin models with the physical system and get the real-time data?
Yes. That would be applying a little different product of ours, which we call Protect My Machine 3D Twin. So now the 3D Twin, I would have effectively created the environment in my virtual machine. Once I have the setup, everything on the 3D side, and also my NC programs and all that, a simple export mechanism allows me to import it into the twin. And now the twin now turns into a collision avoidance product. So there, it's now real-time one-to-one. If you haven't been on the channel, check out the Mr. CNC YouTube channel. We did a really nice YouTube live video on that topic. So when you get to the channel, make sure you click on the live video sections because you'll have regular videos and then you'll have lives. And look there, we did a whole video on Protect My Machine 3D Twin. I would say that's the next step in using these digital twins.
Another question. If I modify a program and set up on my physical tool, is there a direct connection to update the digital twin automatically? For example, updating cutting parameters or offsets at the machine.
So when it comes to the part program, if you do the same process that I did, which is work from a common shared folder, then the digital twin knows immediately what I've done from the machine tool as well, right? Because I'm actually running the program that's sitting on a server. In this case, the server happens to be the same PC I'm running my virtual machine software on, but it could be anywhere. And now that's connected one-to-one. Now, as far as the tooling perspective would go, we do kind of keep them separate. So if I needed to make any updates on the digital twin, I then would probably export my tool INI file, or there's a couple different paths to pull data back out of the machine, but it would be a second step. So meaning if I change the cutter diameter on the real machine, that's not going to immediately reflect there.
Okay.
But it would, real quick, it would in the Protect My Machine 3D Twin. That's a little different beast because that's fully being driven by the real NC.
This question revolves around AI. Is it theoretically possible for our virtual CNC to take instructions from our AI to redesign a critical part, which would improve the efficiencies of our entire system, which is also a digital twin?
Yes, so we are actually actively working on that, not only internally, but we do have a few other partners. One of the ones that comes to mind immediate is Lambda Functions that is working in that AI area, right? So can we effectively take things that are being optimized virtually and then realize them in the real? It gets a little bit trickier because we now have to simulate chip load and spindle load because a lot of the AI, at least toolpath optimization, is basing a lot of that based on what the response of the spindle. But we're now embedding physics engines into this process so we could effectively simulate what we think the chip load is going to be doing and then optimize the program accordingly. So a lot of cool stuff being worked on in that area. I would say some of it is just starting to get into the market, but the the rapid progression of AI, I would say expect to see a lot more on that topic in the very near future, because I've already been part of multiple projects from the R&D side that are going in that direction.
Another question in the chat. Will the digital twin sync with SolidWorks? Thanks.
So I don't believe we've done anything with connecting them to SolidWorks yet. What it can do is sync and connect to NX. Makes perfect sense because NX is a Siemens product. We are also starting to create kind of plugins for other CAM solutions to make that workflow easier. You know, obviously in our world, we'd love everybody to design program in NX, run in my virtual machine, and cut parts in a Cinemeric, but we know that's not a perfect world. So we are looking at especially companies that we have strong partnerships with. Mastercam is one of them that we're developing a plugin to just kind of streamline that flow. Unfortunately, we haven't done anything with SolidWorks as of yet, but it wouldn't surprise me in the near future.
How accurate are the cycle times in the CNC Digital Twin, by the way?
So I've done a lot of testing in this area. I would say on like a 1 hour part cycle time, I will be within 2-3% of what I'm seeing in the reel. Now, again, that is obviously up to the point where everything's running at 100%. You know, as a machinist, we all know I'm going to optimize my chip load on that first part, so my override may be over and under. But if I'm strictly looking at a 1-to-1 and everything's sitting at 100%, it is extremely close. Like I was saying earlier, I think the one area that may give you a slight discrepancy is just any non-NC axis motion. So a tool changer that doesn't use servos, it's using, you know, pneumatics and other things. That's a little trickier to set the timing. We can do it. How many OEMs are going to go that far of putting in all of those, you know, effectively creating a behavior model for all those non-NC components? So that's usually where you see the discrepancy. But I would say easily 2% off of the.
And
right, so 98% accuracy.
And speaking of OEMs, there's a question about having multiple machines from different OEMs in Run My Virtual Machine. Is that possible?
Yeah, absolutely. We do it all the time. So effectively, you're going to have, again, that digital twin file. I mentioned it as a VCP file. That's going to be sitting on what we like to call our workbench. And I'm just going to have a list of all these different machine tool builders or physical machine tools from all sorts of different builders. So I can, jump from a DMG to a DN Solutions to a Track to a Fryer, you know, any of these builders, as long as they're using Cinemeric 1, you can have this environment.
Another question in the chat. Can this be used with laser cutting and punching machines with Cinemeric controllers? And I guess it's a two-part question. Is only Cinemeric 1 required?
Yes. So, well, actually, let me rephrase that. So we've just recently released a version of this that supports the A28 control. So you can do the My Virtual Machine product on an 828 or a Cinemeric 1. So those would be the two primary controls it's supported. I have not been part of any laser. I would have to see if we have any way of simulating the beam to do the cutting. I will say we've already done additive with this. We've done a lot of robotic applications with it. The punching, I think we could do it by using the form of the tool, as long as we bring the tool in as either a step or an STL file. I would expect we could, but I don't have any firsthand knowledge of that.
Okay. Let me check the question panel again. And while I do that, I'm going to throw out a quick poll to the audience, if you don't mind. And let me also check the chat panel for questions. Can the digital twin be used with Cinemeric 840D, Chris? Okay.
So, gentlemen, earmuffs, please.
Especially Dave.
Officially, no. Unofficially, yes, I've done it. You can run into some discrepancy on cycles because, it's going to run the latest and greatest cycle formats. So there could be a little bit of incompatibility from cycles. I think the bigger lift would be just finding an integrator that could build your VCP environment. That's the tricky part. But can it do it? Shh. Yes.
All right. I don't see any more questions in the question panel, nor do I see any more in the chat.
Well, this was certainly an awesome Q&A session. So I thank everybody for some really lively and great questions. Hopefully I answered them okay.
One of the most popular webinars with this amount of questions. So yeah,
For sure.
I fully agree.
Then also maybe add in there for support on your 840D.
Call Dave.
Call Dave.
You have Pollack.
Time to go. Bye, Dave. Bye. No, we are here to help you guys for sure. However we
Chris,
can.
really quick, I have two questions.
Shoot.
One, are we going to be able to get these delivered to our customer by Friday? And then
I'm having a beer after this. Who are you kidding? I'm going to try the prototype we just made.
I get it. If you're like QS or ISO, I mean, you're checking 10%, right? So that's 40 beers, maybe?
There you go. It'll be a good night.
Okay.
Good night at the Pollack residence. Yes.
Right? And then earlier in our presentation, when we were doing the scripting and font, you referenced our part as a putter, which I thought to myself,
no, I did not.
Maybe,
what are you talking about?
Maybe you could help me with my golf game later. We can take this offline and talk about it again. But
look at that beauty, huh? Look at that beauty.
Yeah.
We can make putters. Maybe we can do an event sometime and talk about how we created these. If any of you guys had the opportunity to stop by our IMTS booth, we were made and raffled off 30 of these things, John? I mean, it's a ton. Exactly. I have to say my machine tool was certainly humming, cutting all these. I think it was all 304 stainless, but fun project. So we could maybe play around with that in the future. I would be open to that.
Yeah, and even after IMTS, the requests for those kept coming in. I mean, you could have a side business doing that.
Yeah, except the problem is we could never actually make what we need to make out of. It'd be a $2,000 putter.
Exactly. All right, then with that, we will bring this webcast to a close. Don't forget, if you want to read about some fantastic insights around the use of the CNC Digital Twin, make sure to download the white paper we've provided. You'll find the download link in the upper right corner of your screen. Thank you, Chris and Dave, for this really awesome discussion this afternoon. Thanks to all of you in the audience for joining us today. As always, it's been an absolute pleasure. Take care, everyone.
Thank you. Bye, guys.
Thanks, everybody.